System analysis and design requirements modeling. When you finish this chapter, students will be able to describe systems analysis phase activities, explain joint application development, JAD, rapid application development, RAD, and agile methods. Use a functional decomposition diagram, FDD, to model business functions and processes. Describe the Unified Modeling Language, UML, and examples of UML diagrams. List and describe system requirements, including outputs, inputs, processes, performance, and controls. Explain the concept of scalability. Use fact-finding techniques, including interviews, documentation review, observation, questionnaires, sampling, and research. Define total cost of ownership, or TCO. Conduct a successful interview, and develop effective documentation methods to use during systems development. This chapter describes requirements modeling techniques and team-based methods that system analysts use to visualize and document new systems. This also discusses system requirements and fact-finding techniques, which include interviewing, documentation review, observation, surveys and questionnaire sampling, and research. The overall objective of the system analysis phase is to understand the proposed project, ensure that it will support business requirements, and build a solid foundation for system development. In this phase, you use models and other documentation tools to visualize and describe the proposed system. The system analysis phase includes the four main activities as shown in the figure. We have requirements modeling, data and process modeling, object modeling, and consideration of development strategies. Although the waterfall model shows sequential SDLC phases, it is not uncommon for several phases to interact during the development process, just as they would in an adaptive model. For example, this occurs whenever new facts are learned or system requirements change during the modeling process. Requirements modeling, which involves fact-finding to describe the current system and identification of the requirements for the new system, such as outputs, inputs, processes, performance, and security. Outputs refer to the electronic or printed information produced by the system. Inputs refer to necessary data that enters the system, either manually or in an automated manner. Processes refer to the logical rules that are applied to transform the data into a meaningful information. And performance refers to system characteristics such as speed, volume, capacity, availability, and reliability. Security refers to hardware, software, and procedural controls that safeguard and protect the system and its data from internal or external threats. Data and process modeling entails how to represent graphically system data and processes using traditional structured analysis techniques. Object modeling refers to another popular modeling technique. While structured analysis treats processes and data as separate components, object-oriented analysis combines data and the process that act on the data into things called objects. These objects represent actual people, things, transactions, and events that affect the system. In development strategies, you will consider various development options and prepare for the transition to the system design phase of the SDLC. You will learn about software trends, acquisition and development alternatives, outsourcing, and formally documenting requirements for the new system. The deliverable or end product of the system analysis phase is a system requirements document, which is an overall design for the new system. In addition, each activity within the systems analysis phase has an end product and one or more milestones. You will need strong analytical and interpersonal skills to build an accurate model of the new system. The analytical skills enable you to identify a problem, evaluate the key elements, and develop a useful solution. Interpersonal skills are especially valuable to a system analyst who must work with people at all organizational levels, balance conflicting needs of users, and communicate effectively. Because information systems affect people throughout the company, you should consider team-oriented strategies as you begin the system analysis phase. The IT department's goal is to deliver the best possible information system at the lowest possible cost in the shortest possible time. To achieve the best results, system developers view users as partners in the development process. Greater user involvement usually results in better communication, faster development times, and more satisfied users. Joint Application Development or JAD is a user-oriented technique for fact-finding and requirements modeling. Because it is not linked to a specific development methodology, systems developers use JAD whenever group input and interaction are desired. Another popular user-oriented method is Rapid Application Development or RAD. RAD resembles a condensed version of the entire SDLC, with users involved every step of the way. While JAD typically focuses only on fact-finding and requirements determination, RAD provides a fast-track approach to a full spectrum of system development tasks, including the planning, design, construction, and implementation. Agile methods represent a recent trend that stresses intense interaction between system developers and users. Joint Application Development or JAD is a popular fact-finding technique that brings users into the development process as active participants. Users have a vital stake in an information system or IS, and they should participate fully in the development process. Until recent years, the IT department usually had sole responsibility for systems development, and users had a relatively passive role. During the development process, the IT staff would collect information from users, define system requirements, and construct the new system. At various stages of the process, the IT staff might ask users to review the design, offer comments, and submit changes. Today, users typically have a much more active role in systems development. IT professionals now recognize that successful systems must be user-oriented, and users need to be involved, formally or informally, at every stage of the system development. One popular strategy for user involvement is a JAD team approach, which involves a task force of users, managers, and IT professionals that works together to gather information, discuss business needs, and define the new system requirements. As shown in the table are the typical JAD participants and roles. We have the JAD project leader who develops an agenda, acts as a facilitator and leads the JAD session. Top management who provides enterprise-level authorization and support for the project. The managers who provide department-level support for the project and understanding of how the project must support business functions and requirements. Users who provide operational level input on current operations, desired changes, input and output requirements, user interface issues, and how the project will support day-to-day tasks. The system analysts and other IT staff members who provide technical assistance and resources for JAD team members on issues such as security, backup, hardware, software, and network capability. And recorder who documents results of JAD sessions and works with system analysts to build system models and develop case tool documentation. Compared with traditional methods, JAD is more expensive and can be cumbersome if the group is too large relative to the size of the project. Many companies find, however, that JAD allows key users to participate effectively in the requirements modeling process. When users participate in the systems development process, they are more likely to feel a sense of ownership in the results and support for the new system. When properly used, JAD can result in a more accurate statement of system requirements, a better understanding of common goals, and a stronger commitment to the success of the new system. Rapid Application Development or RAD is a team-based technique that speeds up information systems development and produces a functioning information system. Like JAD, RAD uses a group approach but goes much further. While the end product of JAD is a requirements model, the end product of RAD is the new information system. RAD is a complete methodology with a 4-phase life cycle that parallels the traditional SDLC phases. Companies use RAD to reduce cost and development time and increase the probability of success. RAD relies heavily on prototyping and user involvement. The RAD process allows users to examine a working model as early as possible, determine if it meets their needs, and suggest necessary changes. Based on user input, the prototype is modified and the interactive process continues until the system is completely developed and users are satisfied. The project team use case tools to build the prototypes and create a continuous stream of documentation. The RAD model consists of 4 phases: requirements planning, user design, construction, and cut-over. The requirements planning phase combines elements of the systems planning and systems analysis phase of the SDLC. Users, managers, and IT staff members discuss and agree on business needs, project scope, constraints, and system requirements. The requirements planning phase ends when the team agrees on the key issues and obtains management authorization to continue. User design, or during the user design phase, users interact with systems analysts and develop models and prototypes that represent all system processes, outputs, and inputs. The RAD group or subgroups typically use a combination of JAD techniques and case tools to translate user needs into working models. The construction phase focuses on program and application development tasks similar to the SDLC. In RAD, however, users continue to participate and still can suggest changes or improvements as actual screens or reports are developed. The cut-over phase resembles the final task in the SDLC implementation phase, including data conversion, testing, changeover to the new system, and user training. Compared with traditional methods, the entire process is compressed. As a result, the new system is built, delivered, and placed in operation much sooner. The main objective of all RAD approaches is to cut development time and expense by involving users in every phase of systems development. Because it is a continuous process, RAD allows the development team to make necessary modifications quickly as the design evolves. In times of tight corporate budgets, it is especially important to limit the cost of changes that typically occur in a long, drawn-out development schedule. In addition to user involvement, a successful RAD team must have IT resources, skills, and management support. Because it is a dynamic, user-driven process, RAD is especially valuable when a company needs an information system to support a new business function. By obtaining user input from the beginning, RAD also helps a development team design a system that requires a highly interactive or complex user interface. RAD has advantages and disadvantages compared with traditional structured analysis methods. The primary advantage is that systems can be developed more quickly with significant cost savings. A disadvantage is that RAD stresses the mechanics of the system itself and does not emphasize the company's strategic business needs. The risk is that a system might work well in the short term, but the corporate and long-term objectives for the system might not be met. Another potential disadvantage is that the accelerated time cycle might allow less time to develop quality, consistency, and design standards. RAD can be an attractive alternative. However, if an organization understands the possible risks. Agile methods attempt to develop a system incrementally by building a series of prototypes and constantly adjusting them to user requirements. As the Agile process continues, developers revise, extend, and merge earlier versions into the final product. An Agile approach emphasizes continuous feedback, and each incremental step is affected by what was learned in the prior steps. As Agile methods become more popular, a large community of Agile-related software and services has evolved. Some Agile developers prefer not to use case tools at all and rely instead on whiteboard displays and arrangements of movable sticky notes. This approach, they believe, reinforces the Agile strategy: simple, rapid, flexible, and user-oriented. Scrum is another agile approach. The name is derived from the rugby term scrum, where team members prepare to lunge at each other to achieve their objectives. The systems development version of Scrum involves the same intense interaction, though more mental than physical. In a Scrum session, Agile team members play specific roles, including colorful designations as pigs or chickens. These roles are based on the old joke about the pig and chicken who discuss a restaurant where ham and eggs would be served. However, the pig declines because that role would require a total commitment, while for the chicken, it would only be a contribution. In the Agile world, the pigs include the product owner, the facilitator, and the development team, while the chickens include users, other stakeholders, and managers. Scrum sessions have specific guidelines that emphasize time blocks, interaction, and team-based activities that result in deliverable software. Agile or adaptive methods are very flexible and efficient in dealing with change. They are popular because they stress team interaction and reflect a set of community-based values. Also, frequent deliverables constantly validate the project and reduce risk. However, some potential problems exist. For example, team members need a high level of technical and interpersonal skills. Also, a lack of structure and documentation can introduce risk factors. Finally, the overall project may be subject to significant change in scope as user requirements continue to evolve during the project. Models help users, managers, and IT professionals understand the design of a system. Modeling involves graphical methods and non-technical language that represent the system at various stages of development. During requirements modeling, you can use various tools to describe business processes, requirements, and user interaction with the system. System analysts use modeling and fact-finding interactively. First, they build fact-finding results into models. Then, they study the models to determine whether additional fact-finding is needed. To help them understand system requirements, analysts use functional decomposition diagrams, business process models, data flow diagrams, and unified modeling language diagrams. Any of these diagrams can be created with case tools or standalone drawing tools if desired. A functional decomposition diagram or FDD is a top-down representation of a function or process. Using an FDD, an analyst can show business functions and break them down into lower-level functions and processes. Creating an FDD is similar to drawing an organization chart. You start at the top and work your way down. FDDs can be used at several stages of systems development. During requirements modeling, analysts use FDDs to model business functions and show how they are organized into lower-level processes. Those processes translate into program modules during application development. A business process model or BPM describes one or more business processes such as handling an airline reservation, filing or filling a product order, or updating a customer account. During requirements modeling, analysts often create models that use a standard language called Business Process Modeling Notation or BPMN. This includes various shapes and symbols to represent events, processes, and workflows. Using BPMN terminology, the overall diagram is called a pool, and the designated customer areas are called swim lanes. Working from a functional decomposition diagram, analysts can create data flow diagrams or DFDs to show how the system stores, processes, and transforms data. The Unified Modeling Language or UML is a widely used method of visualizing and documenting software systems design. UML uses object-oriented design concepts, but it is independent of any specific programming language and can be used to describe business processes and requirements generally. UML provides various graphical tools such as use case diagrams and sequence diagrams. During requirements modeling, a system analyst can utilize the UML to represent the information system from a user's viewpoint. Use case diagrams, sequence diagrams, and other UML concepts. During requirements modeling, systems analysts and users work together to document requirements and model system functions. A use case diagram visually represents the interaction between users and information system. In a use case diagram, the user becomes an actor with a specific role that describes how he or she interacts with the system. System analysts can draw use case diagrams freehand or use case tools that integrate the use cases into the overall system design. The figure shows a simple use case diagram of a sales system where the actor is a customer and the use case involves a credit card validation that is performed by the system. A sequence diagram shows the timing of interaction between objects as they occur. A system analyst might use a sequence diagram to show all possible outcomes or focus on a single scenario. A system requirement is a characteristic or feature that must be included in an information system to satisfy business requirements and be acceptable to users. System requirements serve as benchmarks to measure the overall acceptability of the finished system. System requirements fall into 5 general categories: outputs, inputs, processes, performance, and controls. For output examples, we have the website must report online volume statistics every 4 hours and hourly during peak periods. The inventory system must produce a daily report showing the part number description, quantity on hand, quantity allocated, quantity available, and unit cost of all sorted by part number. Third example, the contact management system must generate a daily reminder list for all sales reps. The purchasing team or system must provide the suppliers with up-to-date specification. Fifth example, the sales tracking system must provide or produce a daily fast-moving item report listing all products that exceed the forecasted sales volume grouped by style, color, size, and reorder status. The customer analyst system must produce a quarterly report that identifies changes in ordering patterns or trends with statistical comparisons to the previous 4 quarters. For input examples, first we have manufacturing employees must wipe their ID cards into online data collection terminals that record labor costs and calculate production efficiency. Second, the department head must enter overtime hours on a separate screen. Third, student grades must be entered on machine scannable forms prepared by the instructor. Fourth, each input form must include date, time, product code, customer number, and quantity. Next, data entry screens must be uniform except for background color, which can be changed by the user. And last, a data entry person at the medical group must input patient services into the billing system. For process examples, first, the student record system must calculate the GPA at the end of each semester. Second, as the final step in your year-end processing, the payroll system must update employee salaries, bonuses, and benefits and produce tax data required by the IRS. Third, the warehouse distribution system must analyze daily orders and create a routing pattern for delivery trucks that maximizes efficiency and reduces unnecessary mileage. Fourth, the human resources system must interface properly with the existing payroll system. Next, the video rental system must not execute new rental transactions for customers who have overdue videos. And then last, the prescription system must automatically generate an insurance claim form. For performance examples, first, the system must support 25 users online simultaneously. Second, response time must not exceed 4 seconds. Third, the system must be operational 7 days a week, 365 days a year. Fourth, the accounts receivable system must prepare customer statements by the 3rd business day of the following month. Next, the student record system must produce class lists within 5 hours after the end of registration. And then last, the online inventory control system must flag all low stock items within 1 hour after the quantity falls below a predetermined minimum. For control examples, first, the system must provide log-on security at the operating system level and at the application level. Second, an employee record must be added, changed, or deleted only by a member of the Human Resources Department. Third, the system must maintain separate levels of security for users and the system administrator. Next, all transactions must have audit trails. The managers of the sales department must approve orders that exceed a customer's credit limit. And lastly, the system must create an error log file that includes the error type, description, and time. Scalability refers to a system's ability to handle increased business volume and transactions in the future. Because it will have a longer useful life, a scalable system offers a better return on the initial investment. To evaluate scalability, you need information about projected future volume for all outputs, inputs, and processes. For example, for a web-based order processing system, you would need to know the maximum projected number of concurrent users, the periods of peak online activity, the number and types of data items required for each transaction, and the method of accessing and updating customer files. Even to print customer statements, you need to know the number of active accounts and have a forecast for 1, 2, or 5 years, because that information affects future hardware decisions. In addition, with realistic volume projections, you can provide reliable cost estimates for related expenses such as postage and online charges. Similarly, to ensure that a web-based hotel reservation system is sufficiently scalable, you would need to project activity levels for several years of operation. For example, you might forecast the frequency of online queries about room availability and estimate the time required for each query and average response time. With that information, you could estimate server transaction volume and network requirements. After watching this video, kindly send me a message for me to give you your question. The question will be considered as part of your quiz. Thank you and God bless.